Good morning, good evening, good afternoon, and welcome back to another math lesson. Today we are going to wrap up the transformations unit by going over lesson number 5, inverse relations. So let's get started. We are going to recall a reciprocal function is represented by y is equal to 1 over f of x. So note the following characteristics of reciprocal graphs. The reciprocal graph will always be on the same side of the x-axis as the original. So if the original is above the x-axis, the reciprocal will also be above. If the original is below, then the reciprocal will be below as well. Okay, so I'm going to highlight the first one here. That's actually really important for us to know. Okay, 2, the vertical asymptotes are drawn at the x-intercepts of the original. So the equation of the line is of the form x equals a constant. So in the above graph, the equation of the vertical asymptote will be at x is equal to 0. 3, horizontal asymptotes are may also be present in the reciprocal graph. Oh, man, that typing needs some work. Yes, so horizontal asymptotes may also be present in the reciprocal graph. So the equation of the horizontal line is of the form y is equal to a constant. So in the above graph, the equation of the horizontal asymptote is that y is equal to 0. 4, invariant points are points that don't change position when a transformation is applied. So in reciprocal graphs, the invariant points are located at y is equal to 1 and y is equal to negative 1. Okay, for the horizontal asymptotes part, you'll learn more about that in another unit that I've done called radicals and rationals. Okay, so I'll leave a link in the description that'll take you to that. Okay, but that is the characteristics of reciprocal graphs. So, for example, if we were to look at this particular graph, okay, we can discover a few things. One of them being the vertical asymptote. So the vertical asymptote is going to be at wherever it crosses the x-axis. So it's going to cross the x-axis here. So that is going to be our vertical asymptote. We will also have a horizontal asymptote in this case, and y is equal to 0. Okay, so we can create a horizontal asymptote at this point. And lastly, next, are our invariant points. So our invariant points are located at y is equal to 1 and y is equal to negative 1. Okay? And finally, the last bit is that if the graph of the reciprocal function will be on the same side of the x-axis as the original one. Okay? So it's going to follow the asymptote. It's going to touch this invariant point and continue on. Do you notice how this top part of the graph for our reciprocal graph is in the same direction or the same quadrant as the original? Same can be said for this bottom one. Okay, it follows the same idea. It's going to follow the asymptote. It's going to touch this point and it's going to continue on in this quadrant. Now, you can see that once it reaches the lower half of the once it reaches the lower half or below the x-axis, well, that's where this reciprocal graph will also be as well. It'll also be in below the x-axis as well. So you can see how it's split into the two. So note, the point xy becomes the point x and 1 over y. Okay, so that's what it becomes. And that's what we've seen here. That's why we have invariant points at y equals 1 and y equals negative 1. Because those are the exact same spots, right? 1 over 1 gives you the exact same. Negative 1 over 1 gives you the exact same point. That's why we have invariant points at 1, at y equals 1, and y is equal to negative 1. Now, we were talking about reciprocal functions before. Now we're going to look at inverse functions or inverse relation. So an inverse relation is defined as x is equal to f of y or y is equal to f negative 1 of x, and may be obtained by interchanging the x and y values. Okay, that's important for us to know, okay, that these are interchanged. So you're going to swap your x and y values. As such, inverses are a relation that has been reflected in and over the line y is equal to x. Okay, so inverse relations are reflected over this particular line. So note the point xy becomes the point yx. Okay, when the inverse is still a function, we use f of -1 of x instead of x is equal to f of y. Okay, so when the inverse is still a function, that's what we have to remember. If it's still a function, it's f of -1 of x, and we don't use x is equal to f of y. Okay, so remember, if the inverse is a function, it will still pass the vertical line test. If it doesn't, it's not a function. For inverses, the invariant points are on y is equal to x, so it's on that particular point. So if a point in your original function lands on the point y is equal to x, your invariant point will be in the exact same spot for the inverse of it, okay? So note that 1 over f of x and f of -1 over x do not mean the same thing. One is a reciprocal, the other is an inverse. So they are two different kinds of graphs, okay? So I'm going to show you in this next example, given the graph of y equals f of x, we are going to sketch the inverse of it. Okay, so what we are going to do is we are going to sketch the inverse of this function. Given the graph of y equals f of x, sketch the inverse. So one thing I would like to show you is that we're going to, again, do the reflection of this over this line, y is equal to x. And so I'm just going to draw a dotted line, okay, just to reiterate that that's what we're doing. So this is y is equal to x. Okay, so we're going to swap the x and y values. Okay, so for this first one, we have, so I'm going to go to the far, actually, no, I'll leave it, I'll read it from left to right. Okay, so the far left point we have is, we have -1, 2, 3, 4, and then -1, 2, 3, 4. So best part is that whenever you have an inverse line, so whenever you have a graph, your original graph, and it's on the line y is equal to x, any point of that, they remain in the same spot. So this entire line here will remain there. Okay, it's the rest of them that's going to change. So I'm going to look at the next point, okay, which is going to be at x. It's at 2 and -2. So now we're going to swap those 2 points. So it's going to become, this new graph is going to be at x is equal to -2 and y is equal to +2. So it's going to look like it's going to go up. It's going to go up to here. So now we can connect these points and it's going to go up here. Okay, and then the last point we have is at, let's see, it's at 4 and 2. So now it's going to be at 2 and 4. So now it's going to be up here. So this is how the graph is going to look. Okay, it looks very similar, but again, it looks like it's been flipped and reflected over the y equals x. Okay, so again, what we can do is we can actually map this out. So if we go the the first one, right, and then y and x. So we had -4, -4. We had -2, -2, right? We had 2 and -2, and then we had 4 and 2. Okay, and when we swap them, right, these two remain the same because they lied on the point. They lied on the line y equals x. So they stayed in the same spot. Plus their x and y values were the same, so they remained in the same spot. Okay, so those are technically our invariant points. And then we have the next one where it's going to be -2 and 2, and then we graph the point of 2 and 4. Okay, so these are our, this is our new function, new inverse function. Okay, so is this inverse a function? Okay, so in order for it to be a function, it has to pass what's called a vertical line test. So that means you would have to draw any dotted line, any dashed or dotted line through the function, through the graph, okay? And if it touches more than 2 points on that vertical line, then no, it will not be a function, okay? So we'll have to say no in this case. It does not pass the vertical line test. Okay, and we can see it when we draw a vertical line right here. Okay, so because of that, multiple points are being touched at this point, so no, it does not pass the vertical line test. And we can say specifically the x value of -2 has more than 1 y value. Okay, and we can see that, but when we actually drew the vertical line test. Okay, so what we're going to do next is we are going to state the domain and range of the function and its inverse. So the original one, so y is equal to f of x. So this is the original function. Your domain looks like it's between -4, right? -4 and 4. So -4 and 4. So this is our domain, and our range, it looks like it's between -4 and 2. So this is going to be -4 and 2. All inclusive, all the values are there, okay? Whereas the next one, x is equal to f of y, right? Because, and we state it this way, because this is not an inverse. Okay. So we cannot say y is equal to the inverse of x. Okay. That's when we say that this is we have to write it in this notation when it is a function. So we write it like this. When it is a function. Okay. The domain and range. Okay, so it's going to be flipped. So whatever your range was will be your domain, and whatever your domain was will be your range. So your domain is going to be between -4 and 2. And your range is going to be in between -4 and 4. Okay, so a quick little note of that as well, to say that your properties of x and y also switch. Okay, so a lot to look at there, but a big thing to remember is that reciprocal graphs and inverse graphs are different. Okay, reciprocal graphs is you just go 1 over y, whereas inverse graphs you swap x's and y's. Okay, so they'll swap values. All right, but that is it for today's lesson on inverse relations. I hope you enjoyed it. And remember, when it comes to math, keep calm and show your work.